All right, today we're going to take a look at section 1.3, which is reasoning and logic. For those of you who have taken contemporary math, you will notice some similarities in this section with some of the things that you probably saw in that course. So, you know, it will come back to haunt you or something like that. Hopefully not, but you will notice some similarities. The first thing that we're going to talk about is some language, some vocabulary. A statement is a sentence that's either true or false. So something like, I ate cereal for breakfast. I either did or I didn't, so it's either true or false. But a non-example, something that would not be a statement, would be the second one, what did I eat for breakfast? Because that would be a question. There's another kind of statement, another kind of sentence, rather, that you can have that would not be a statement, and that's a command. For instance, if you said, you go eat cereal for breakfast, that's not a statement, right? It's not a true or false thing. It's not a question either. It would be a command, so it also would not count as a statement. A negation, so if we have a statement that we call with this little letter P, and we want to talk about the negation, the opposite of it, we put this little tilde in front of it, and we read this statement as tilde P is what I sort of say, but we read this as not P, the opposite of P. So for example, sometimes that's very straightforward and easy. I ate cereal for breakfast. The opposite of that is, I did not eat cereal for breakfast. But notice what it isn't. It isn't, I ate eggs for breakfast. Right? I mean, those are two different statements, but they're not opposites of each other. Now, it's not always that clear how to change something into its opposite. This one was really straightforward. I simply put the word not in. But if you actually have a couple of different kinds of quantifiers in there, it complicates things. So a universal quantifier is one of those. A universal quantifier refers to each and every element in a set. So you'll have language that'll say something like, for all, or every, okay? You know, one of those things like that your mom told you never to do, don't say, you always, ... You guys know what I'm talking about, right? Because if you say you always, or you say you never, the only thing that it takes to make that statement false is exactly one time for your statement to fail, right? So when my son says something like, you're always mad at me, I can say, no, I'm not. Because I got at least one time when I'm not mad at him, right? And the same thing's true for the word never, okay? So if we're taking a look, here's an example. All people are sinners, right? So we've got the word all at the beginning, okay? So those words that apply to everything that comes after it, that word all, the word every, the word never, the word none, all of those are considered universal quantifiers. Existential quantifiers refer to something existing. So you see statements that say something like at least one, or there exists, or some, okay? So something like some cats go to heaven, okay? All cats could go to heaven, and this would still be true, okay? But all that's really saying is a much weaker statement, right? Well, some of them do. At least some of them do. All right, so here's the kicker about these. Universal quantifiers and existential quantifiers make life difficult when you're creating negations. So you got to know how to deal with them properly in order to get negations done correctly when you've got those existential, that there exist, you know, some, or the universal, all, or every, or none. You got to figure out how to deal with those. So let's talk about how we create those those negations when we have those kind of quantifiers. So I've got two examples here. The first one says, all dogs go to heaven. It's got that word all in it, so what kind of quantifier is it? Which one was it? It's universal, okay? So here is the kicker. Here's how you make the decision. If you have a universal quantifier and you want to do a negation, it has to turn into an existential quantifier. So that word all can't stay all. It has to change into something that means there exists, or some, okay? It has to turn into the other kind. So that word all, I'm going to use the word some, but you could use there exists, and that would be okay too. Some. So all turns into some, and that will always happen, okay? Always. You use my word always in there too, right? It will always happen. You have to change it into the other type of quantifier. All turns into some. Notice all cannot turn into none. Why not? Because none is still a universal quantifier. None applies to everything that comes after it. It's like saying never, right? Always and never, those are those key words. They're universal. So I can't turn all into none. I can turn all into some, though. So this is about some dogs now. And what would be the opposite statement? Would it be opposite to say some dogs go to heaven or to say some dogs don't? Which one? Don't, right? That's the opposite of what this says right now. Right now it says all of them do. So in order to make that false, some of them, that is some dogs, would have to not go to heaven. So some dogs don't go to heaven.
So it's like the quantifiers plus the negation. You have to think about those two things.
Yes, yes. So you're trying to make the statement the opposite statement. And what you're wanting to do is you're wanting to make as little difference as possible to actually make the statement false. For instance, if I said no dogs go to heaven, that would be opposite of what originally started out, right? But it'd be overkill. I don't need none of them to go to heaven to make the statement false. Actually, all I really need is one. I only need one dog to not go to heaven to make that first statement false. So we can use the words, at least one, or we can use that statement some. Okay, the next one says some of my classes are hard this semester are hard. So that word some is of what type of quantifier? Existential, which means it needs to change into a universal. And you have two options. What are your two basic options for turning the word some into? All or none. Okay? And you have an option. So I'm going to write both of them down. And one of them will feel more natural. I'm going to use the word no instead of none. No, I'm not. I'm going to use the word none. Sorry, thinking about the way the statement said. We're going to write both statements down. They're both going to be technically correct, but one will actually sound like something you would say in real life, and the other one's going to sound weird. That's what it's going to work, okay? They're both technically correct, though. Everybody with me? Okay. So the word some can change into either the all or the none. So we have two options. All right, so some of my classes are hard. What would be the negation if I used the word all? All of my classes what? All my classes are, what did I hear? You have to be really careful with the word easy.
Not hard?
We're going to go with not hard. Because I don't know about you, but I've had some classes that I would not classify as hard or as easy. There's something in between. Maybe they're not hard or easy, but they're time consuming, or something like this that I wouldn't classify in that way.
Actually change the word.
You don't want to change the word.
Okay.
No.
So just leave it the way it is and negate it, even
Exactly.
if it sounds kind of weird.
And this one sounds weird, doesn't it?
Not hard.
Not hard sounds awkward. Agreed? Yeah. All right, let's try this other one, the word none. What about this one? If I say all of my classes are not hard, that is negating the statement. But what if I start out with the word none? None what? None of my classes are hard. And Nicole, that one sounds better, doesn't it? That's just how you guys would say it. You would say none of my classes are hard. You wouldn't say all of my classes are not hard. It almost sounds like you're doing some sort of a double negation thing going on. And you're not, but that's not how we speak when we speak English. So either one are correct. This one's the one that's a little bit more natural. But either would be okay.
Maybe a dumb question. I know it's going to sound weird, but why do you say one of my classes are not hard? Because you're adding the none in replace of the some, but then you also have to negate it. So like, why wouldn't you?
You have to negate something, but you've already negated it by using the word none.
Okay, so it's
Okay.
negated and it replaces the.
Yeah, this one actually did both at the same time.
Okay.
Exactly. And if you start to say, if you start to reason out what you're actually saying, if you say none of them are not hard, that's equivalent to saying, sort of like saying all of them are easy.
So there's
and
like
that's actually the
positive
opposite.
words and negative words, kind of, right?
There are words, yes, that's true. The word none
Like
already
the
has a
all.
negation involved in it.
Right.
Mhm.
Okay, so you would use that one if you're trying to like make it less, kind of.
The easiest thing I think to do is to try both options, and one of them is going to feel natural and the other one's going to feel weird.
Okay.
And you're going to go with the one that feels like it's natural.
But
You
even
still want to
if
make
we
sure
use
it
the
makes it
other
the
one.
opposite, but
Even if we use the other one, you're not going to kind of
No.
like wrong.
no, because with logic it's actually technically correct. I mean, this is the kind of thing that gets people in trouble in courtrooms, right? They use statements that some people confuse because they use too many negations or something involved. You guys know what I'm talking about, right? You've seen, Law and Order and stuff on television or whatever. If you confuse the way the language is worded too much, things start to sound weird. And they actually were right because we have English, and English is a little bit weird. So either of these are okay, though. So if you do it in a different way, even though it's sort of awkward English, it's still all right. Okay. Here's another thing that you have seen if you've taken contemporary math. You've seen something called truth tables. I know they're your favorite. All right, here's the deal. We're not going to get near as involved in truth tables as you did in contemporary math, okay? We're just going to touch very briefly into them. This is the only section. We're only going to do a few simple examples, okay? Promise. The first one we're going to do is we're going to look at a truth table for a negation. Okay, so a truth table, what it does is it lists all possible true and false patterns for a relationship. So if we've got, just talking about a negation, we've got the statement P, and we've got the statement not P, or tilde P. If the first statement is true, then its negation would be false, yes. And if the first statement were false, then its negation would be true. Okay, so far so good. I haven't lost anyone, right? No, this is good stuff, right? It's when you compound things that things get more difficult, right? All right, so we're going to do compound statements. A compound statement is a statement that is formed by combining two statements together with a connective. And there's several kinds of connectives. One type of connective is called a conjunction. That's like the word and. Another kind of connective is called a disjunction. That's like the word or. And a third type of connective is called an imperative or an implication statement, and that's the if-then connective. Those are the only three kinds of connectives that we're working with. The word but sometimes comes into play. It usually means or, depending on the context. Sometimes it can mean and, but there's usually context enough to decide. All right, so taking a look at this, a conjunction is an equivalent of an and statement, and it's true only if both statements are true. So we're going to deal with statements P and Q. And we have some options. Okay, so I've got two statements. One option is that both statements could be true. So I always make one up when I get here, and I tend to use the one that says that I'm a mother and I'm a teacher. It's one I've used before. Did I use that one last time? Okay. So if I were to say the statement, I'm a mother and I'm a teacher, I am a mother, that's true. I am a teacher, that's true. So both of those individual statements are true. Agreed? So what that means is that the conjunction, which looks like this, it's an upside down sort of a V shape or an arrow, the conjunction would also be true. If both of the individual statements are true, then the conjunction's true. But we, of course, have people who are not both mothers and teachers at the same time, right? So what if you are, we're doing P as though it's a mother, and Q as though it's a teacher, so we're going to make that false. My sister's a dental hygienist. She is a mother. She's got 3 beautiful children, but she's a hygienist. So she is a mother, that's true. She is not a teacher, that's false. So if she walked in the door right now and said to you, and you knew that information, I'm a mother and a teacher, that would be false. Because the word and means both of those pieces has to be true. And they're not. So that's a statement that would be false when it's combined. We have another option. We could have somebody come in and they are not a mother and they are a teacher. So let's say that we had Dr. Sanderson come in. Okay? Dr. Sanderson comes in and he is a he. If you don't know Dr. Sanderson, he is a he. So he is not a mother. Clearly false, right? But he is a teacher. He teaches here at OBU. So if Dr. Sanderson walks in and he says, I am a mother and I'm a teacher, you would say, false. That's not true, right? That can't work out right because you're a man. Not good. All right. The last one is someone who is neither a mother nor a teacher. So let's say that our president, Dr. Whitlock, walks in and he says, I'm a mother and I'm a teacher. You're going to say, no, you're not, right? Because he's not a mother and he's not a teacher, so he's clearly not both. So this also would be false. So in a conjunction, both statements have to be true for the result to end up being true. So there's only one place here that's true in a conjunction. okay, as the final resulting column. A disjunction is an or statement, okay? So with a disjunction, we have the same P, we have the same Q, and we have a conjunction, or I'm sorry, a disjunction with those, and that looks like a V between them, P or Q. And we can use the same situation setup as I just did. I can come in and I can say, I'm a mother or I'm a teacher. And that statement is true. It sounds weird to say it that way because both individual statements are both true, but it would still be true. I can use the word or in between them and it still makes it true. So my sister, she can come in. She can say, I'm a mother or I'm a teacher. Remember, she's the hygienist. And that statement would then be true because she is a mother or a teacher, one or the other. She's okay. She'd be correct in saying that. Dr. Sanderson can walk in and he could say, I'm a mother or I'm a teacher, and that would also be true because he is a teacher. But if Dr. Whitlock walks in and he says, I'm a mother or I'm a teacher, we've got problems because he's neither one of those things, right? So that would still be a false statement. So when you're dealing with a disjunction, you end up with only one false statement in the list. And it's the situation where both individual pieces were false. All right. I don't think I have this written down, and I think you need it later. So let's take a moment and just write in the margin on the side. We're going to do the if-then statement for you. And I'll go to the very end of my slides to put it on there. All right. All right, so if you have an if-then statement, the connective between them looks like an arrow, and we read that as P implies Q. I think you only have one question about this in your text, so it's not going to be a huge amount of things, but I want you to understand how the truth table would work for that. This is the one that's complicated, in terms of thinking through how it works, okay? We still have all the same possibilities before. We could have both statements being true, the first one true, the second one false, the first one false, the second one true, or both statements false. All that stays the same. Those are still the four options. What's different is the resulting column. All right, so I'm going to change my if and my then. I'm going to change my P and my Q statements that I have from what I had before. And let me write them down. I'm going to make the statement for P is I am a mom. And I'm going to make the statement for Q is I am a woman. Okay, no teachers anymore, just moms and women. Okay. So if I made the comment, if I am a mom, then I am a woman, would that be true? Yes, it would definitely be true.
Are we on a certain page?
No, I added it at the end. I just said write it in the margins. Yeah, just write it in the margins because there's one question in your homework that's going to ask you about some imperatives, and so I want to make sure I've mentioned it. All right, so the second one says true, false. So it can't work out that way, right? You can't be, in this case, the way I've set the situation up, you can't be the mom and not be a woman. That won't work, right? So this is absolutely not a way, it can't happen. Okay, you can't be the mom and not be the woman. Okay. However, if you take a look at these last two, they're both possible. Do you see that? You actually could be not a mom and be still a woman. Most of you in this room, does anyone in this room have children? You guys are all row 3. Okay? So this is a true possibility. This is actually something that can legitimately happen. But it's also equally likely that if we had a young man in our classroom, that he would classify in row 4, right? Not a mom, not a woman, and that can equally likely happen too. Is everybody with me? So when you're looking at an imperative, an implication statement, the one with the arrow, the if-thens, the only time that statement is false is when you have true implies false. So when you have a true statement at the beginning and a false statement at the end, that is the only time that will not work. That is the only time it will result in a false statement. Any questions on this? Okay, let me go back then to where we were, which was we were going to do one connected. All right, example 2. We are asked to create a truth table for P and tilde Q. So when you're creating your truth table, you will always have a column for each of the variables or each of the letters that's mentioned. So in this case, that would be a column for P and a column for Q. But you also need a column for any variation of those that are in the problem. So if you notice, I don't have a tilde P in the problem, right? So I don't need a column for tilde P. But I do have a tilde Q in the column, so I will need a column for tilde Q. Okay, everybody good so far? So P and Q are there always by default. Any tildes or anything else after that only occur if they occur in the problem. And this problem had a tilde Q in it. Now, that's actually the only other piece. Like we've got a column representing every piece of the individual statement right here, right? So the only other thing that we need is we need the actual conjunction, that is the joining of these with the and statement, the final answer. The other cool thing about truth tables is column P and column Q are always the same. You guys remember that? They always are the same. So column P always says true, true, false, false. Always. Okay? And column Q always says true, false, true, false. And the reason they always say that is because that gets us all 4 possibilities. That's all combinations of how these actually could be true and or false and combined. Okay, so those are always going to match. And I could be wrong, but I'm pretty sure that this textbook never uses 3 statements. They only use 2, I think. So I may have to tell you later that I lied, but I'm pretty sure that's the case, if I'm remembering right. So, all right, tilde Q then. That's actually based upon what the Q column is. So my Q column says TF, TF. So what will my tilde Q column say? Yeah, exactly the opposite. FT, FT. And please make sure that you guys I can tell the difference between your T's and F's. I don't want to have to guess. If I have to guess, I'm going to pretend that it's the wrong one. Okay, so don't make me guess. All right, so now what we want to do is we actually want to take column P, let me make that thicker, column P and column tilde Q, and I'm going to join them with an and statement. So let's think for a moment, look back if you need to. When is an and statement going to be true? If they're both true. And every other time you're going to get a false. All right. So row 1 says true under P and false under tilde Q. So it says true, false, which is false. Row 2 says true, true, which is true. And then rows 3 and 4 both have falses in them as well, right? False here and false here. And I've got some false over there too, although I don't even need it there. And so those are both false as well. That's a truth table for this compound statement. Now, number 3 asks for something slightly different. What does it ask for? A truth value. It does not ask for a truth table. So here's the cool thing. When you're asked for a truth value, all you're really asked for is one line of a truth table. That's nice, right? I don't need the whole 4, the 4 rows here. I need just 1 row. And I'm going to have to set up the rows or the columns the same way. I'm going to have a column for P, a column for Q, and then I'm going to take a look at the pieces here. So what else do I need besides P and Q individually by default? I need a tilde P, that is a not P. What else? A tilde Q or a not Q. What else? The whole thing. Tilde P or tilde Q. So far so good? And here's why you only need this much. They actually tell you P is false, Q is true. And that's why you don't need all kinds of P's and Q's everywhere, because you're told which one it is. P is false. So right underneath P, I'm going to put false. And right underneath Q, I'm going to put true. Because I was told that that's what it was. See, when you create a truth table, you're not told any of that. You have to explore all possibilities. But there are no possibilities on this one because you're told what they are. So, tilde P, that will be true. Tilde Q, false. And then the last column is an OR statement, and it joins columns tilde P and tilde Q. So when is an OR statement going to be true? When at least one of them is true. So will this statement be true or false? True. Now here's the kicker. At the very end, after you've created this one-line truth table, you have to answer the question. The question says, what is the truth value? It's true. And you have to tell me that it is. It's like interpreting your results, right? It's like the answer to the question after you've done all the work. Make sure you give the actual answer and not just do all the work. Okay. Any questions on that one? All right. Let's talk about what it means for two statements to be logically equivalent, because we actually created a statement that was logically equivalent at the beginning. We did two negations. Do you remember this one back here? All of my classes are not hard and none of my classes are hard. And I didn't use the language, but they are logically equivalent. They mean the same thing. Okay? You have lots of things in English that do that. Well, with the syntax of what we're talking about, two statements are going to be logically equivalent when they have the same truth value in every possible situation. And the way that we write that they're logically equivalent is you see a P and you see 3 lines between them. And you may have seen that in some geometry course somewhere, because that's not altogether uncommon notation when you're saying something is exactly equal to something else. That's the notation we're using here. Those are logically equivalent. De Morgan's laws actually produce for us logically equivalent statements. So let's take a look at De Morgan's laws and see if you can see what's going on. So you've got a negation outside of an AND statement here on the first one, and you've got a negation outside of an OR statement here. Everybody with me on that? So you're negating an AND statement or you're negating an OR statement. So when you negate an AND statement, what does it say you have to do? Well, it says you need to negate the first piece. It says you need to negate the second piece, but what goes in the middle? The word OR. Okay. The opposite of an AND statement being true is that either one or the other, or it could be both, of the individual statements is going to be false. It's the exact opposite. So the negation or the opposite is actually making either piece or both false with the OR in the middle. And the same thing happens on the second one here. So if I'm negating an OR statement, I negate each piece. And I also change my sign in the middle too, right? So the negation of an OR statement is logically equivalent to negating each of those pieces and turning the OR into an AND. Both of those things have to happen. So if you take a look at this one right here, we're going to use De Morgan's laws to write the negation. So the negation, here's what we're being told to do. We want the negation of P and tilde Q. Okay, so this is what we're asked to find, and what we're wanting to use is those De Morgan's laws to write the other side of the triple inequality or triple equality thing. What is the other side going to look like? So how will it start out when I sort of look at this negation? Not P. I need to negate the first piece. What symbol will go in the middle? The OR symbol. And then what happens when I negate the negation of Q? You just get Q. Kind of like when we're working with numbers and we say the opposite of -5 is 5, right? The opposite or the negation of negative Q, or the negation of Q is Q. So this is actually what we're looking for, okay? There's not a lot of work to show. We're just using De Morgan's laws to rewrite it. However, if you take a look on example 5, what we're going to do is we're going to verify that they really are logically equivalent. And the way that we're going to do that is with truth tables. Our truth tables can actually show us that that really did work. So here's what we're going to do. We're going to use the first one right here that was given to us, and we're going to create a truth table. And you may need to actually use some of those line spaces on the side because this is going to take a little bit of space. And then we're going to create a truth table with this piece right here that we created. Okay, so 2 separate truth tables. Or you can do it all on one truth table, compare the columns. That's another way of doing it. Okay, I'm going to do it as truth tables just so you can see the difference between the two, that I'm not sort of running it together. Okay, and what we're looking at is we're looking at the final result. All right, so we've got P, we've got Q, And if you take a look, we're working inside out on parentheses, just like, back in algebra. You start on the inside of the parentheses. What do you see on the inside that I don't yet have? I see a tilde Q as well. I need that. What else do you have inside those parentheses? The and statement first, right? The P and tilde Q. And then the last thing you see is actually the piece on the outside which negates that, yeah? Okay, does that make sense? Okay, so we talked about this already. How will column P look? What will it say? True, true, false, false. How about column Q? True, false, true, false. How about column tilde Q? Okay, let me pause there. Anybody have any questions so far? Those three columns you should be able to create in any situation. It's the next part that makes things different. All right, so the next part says that I'm supposed to take column P and column tilde Q, and I'm going to compare them with the conjunction and. When is an and statement true? When they're both true. So on row 1, I have true, false, which is. On row 2, I have true, true, which is. On row 3, I have false, false. And on row 4, I have false, true, which is false. Now, what do I have to do for my last column? Negate the column before, right? So I can take the false, and it will turn into a. I can take true, and it will become. False becomes. And true. False becomes true. Okay, so this is the first of my truth tables. I'm going to attempt to put the other two, or the other one over here. We'll see if I have space. Okay, the other one is supposed to do this statement right here. So I've already wrote down my P, I've already wrote down my Q. What else do I need? I need a tilde P. And then I need the whole thing, right? The tilde P or Q. Okay, column P says what? True, true, false, false. Column Q? True, false, true, false. Now tilde P will say what? False, false, true, true, because I'm going back to column P, the very first column, to do that. And then I'm told that I'm supposed to take tilde P and tilde Q, and I'm supposed to compare them with the disjunction or. So when is an or statement true? When one of them is true. What about when both of them is true? It's also true. Okay, so if either of them are true, then it's true. So on the row 1, the ones that are highlighted in pink, I have true, false, which is true. Row 2, I have false, false. Row 3, I have true, true. And row 4, I have false, true. And look at those. What do you see? They match, don't they? And the reason they match is because they're logically equivalent. So this actually proves that they were logically equivalent. All right, last thing before we go, we're going to use De Morgan's laws for this statement because it's easy. It's just a writing one. I'm supposed to use De Morgan's laws to write a negation of the statement. It is not sunny, and I will go for a walk. So there are 3 pieces that you have to negate. There's the first statement, there's the connective in the middle, and then there's the last statement. So what is the opposite of it is not sunny? The negation of that. It is sunny. Don't start talking to me about clouds. Okay, we already talked about this. Don't change the actual pieces of the statement. What do I do with the word and?
Or.
That becomes an or. And what is the negation of I will go for a walk? I will not go for a walk. So the negation of it is not sunny and I will go for a walk is it is sunny or I will not go for a walk.